I've shown you so far this unit. Hill-Sass, 30, 60, 90, 45, 45, all that sine, cosine, tangent business. You can only have what type of triangle? That's ridiculous. Ridiculous that you can only do this in a right triangle. And honestly, how often are we given a right triangle? Not too much. So why can't I find a side or an angle in any triangle? Why does it have to be a right one? Well, this last part of the unit, I'm going to show you how to find a side or an angle, any type of triangle, even a right triangle. All right, I'm going to give you 2 formulas today and tomorrow that no matter what the triangle looks like, you'll be able to find a side and an angle. All good? So that's what we're doing this last part. No more right triangles, but I still want a side and an angle. How do I do it? All right, let's just hop right into it. I like just hopping right into a problem and discussing it as we go. This first example, I got triangle ABC. You guys see my new notation? Side A, side C, the ones across from the angles. I'm asking you to solve this triangle. Solve it. Anybody want to remind me of the directions when I ask to solve a triangle? I'm looking for what here? Anything that's missing, you better find. Any angles or sides. So I think the only thing we can find right now is, can you find the third angle for me? I don't need a fancy formula or anything. Find the third angle. What's angle C here? Come on, don't do this to me. Don't overthink it. What's the third angle up there? 3? Even, what's my third angle? 30 degrees, because even knows there's 180 degrees in the triangle, right? All good. All right, now we're stuck. Everything I've shown you this unit, useless because this isn't what? What type? This is not what type of triangle? It's not a right triangle, so everything I've shown you is useless. So let me show you something you can use in any type of triangle to find a side. Called the Law of Sines. The Law of Sines. Here's what it says. Let me first write out the formula, and then we'll use it on this problem. Here's what the Law of Sine says. It's a proportion. It's a proportion. Here's what it says. Take any side in a triangle. So I'll say side A. Make a ratio with it with the sine of the angle across from it. So that's why I'm going to put capital A for angle A. So if you take the ratio of a side and put it over the sine of the angle, it's in the same ratio in the same triangle as another side, I'll call B, that's just a second side, over the sine of its angle across. Those ratios are always equal to each other. So that's what we're going to use today to find sides and angles. Law of sines. One more time. A is a side, and I put that over the sine of the angle across. B is a side, and I put that over the sine of the angle across from it. All right, big decision for somebody here. 17. Which side do you want to find in this diagram? No wrong answer.
I guess BC.
A?
Or A.
Thank you. All right, here we go. So here we go, everyone. We're going to find side A using law of sines, because I can't use sine, cosine, tangent. It's not a right triangle. All right, using law of sines. Here we go. First one, why don't we just start with the side we're looking for? A over, what's the angle across from A? Side A, what's the angle across? What's the measure of it? 110. But whoa, I don't put 110 here. Read the formula. I put what? Not 110, but the sine of 110. See how it's working? That's in the same ratio as, now what I want to put here is an actual side and angle relation I know. All right, I don't want to put C here and have 2 different variables. Give me a side and an angle relation I know. What side do I know? B, 28. And I'm going to put that over, what's the angle across from 28? 40. Not 40, but sine 40. All right, take a peek at that before we solve it. Side over the sine of the angle across. Questions? How do I solve it? It's a proportion. Proportions, cross multiply. We've been doing it, I think, for almost a month now. I'll help you. Sine of 40 times A equals, here we go, sine of 110 times 28. Oh, here come the bags opening and the calculators being fired up. I'm solving for side A. What do I need to do on both sides to get A by itself? Divide both sides by sine 40. Yep. Sine 40. So A, side A will be equal to, let's go to your calculator. Pop it. You don't have to use a fraction template. I do, but you don't have to. So let's get the fraction template up. On the numerator, what do I got? Sine 110 times 28. Sine of 110. Close that sucker up, times 28. And on the bottom, sine of 40. Yep. Sine 40. And make sure we round to the nearest tenth. 40.9. Are there any units on this one? Or no? All right, so I'll just leave it 40.9. Woo! You okay on A? We still got to find side C to solve the triangle. Can't use Pythag, it's not a right triangle, so I'm going to use law of sines again. So let's find side C. So give me that side C. Now what do you want to put it over? What do we want to put this over? What's the angle across? 30. Sine 30. Don't forget your sine. Equals, my preference, I always use the given side and angle. Now, whoa! Hey, you don't have to. You can use the answer you just got, but why am I not going to allow you to use 40.9? What am I going to have you put in instead? The non-rounded answer. So that's your call. All right, you want to use the non-rounded answer over sine of 110, that's fine. I always prefer just to go with the given ones. 28 and sine of 40 again. Woo! Cross multiply. Sine of 40 times C equals 28 times sine 30. And then divide both sides by sine 40. Side C, 21.8. Look all right, 21.8. Don't go on to the next one. I want to talk about something. Most of you guys, not everybody, being in honors, if there's a way to see if you're right or wrong, you probably want to see if you're right. All right, instead of just flying on to the next problem. So look back at my triangle right here. We found at the beginning that was 30. We just found that A was 40.9 and C was 21.8. Now look at that triangle. Anybody want to tell me why I'm pretty confident that we found the right values based on a theorem from a previous unit? I'm pretty confident going on to question 2 that we probably found the right ones here. What's up, Tammy?
Like the smallest side across from the smallest angle.
Remember, in a triangle, where's the smallest side located? Across from the smallest angle, biggest side across from biggest angle. So I'm pretty confident. So that's the way you can do a little quick check before you move on. All good? All right. Don't worry, I'm not going to ask you to solve any more triangles. I don't have that much time, and I know you don't have that much patience. All right, set up your diagram. Sorry, I don't provide the triangle here for you. So we have triangle DAT. Everyone's got that triangle? Two, three, I got 4, 5, 6. Okay, I'll just keep going. Just keep setting up that triangle. Everybody, that triangle. All right, never mind. I knew after second period's reaction I wasn't going to get much here to begin with. So, side T, 21. And ask your group mates if you haven't figured it out with that triangle. I look forward to this every year too. Find side D. Find D. So I look across from angle D. I'm looking for this side right here. Right, that side right there. All right, start law of sines off for me. I'm looking for side D. Now I'm going to start calling on you guys. What am I going to put in the denominator of side D? 11. Who's got 11? Oh, hold on. Is that you, Paul?
Yeah.
Sorry, let me rephrase my question so you pick it up here. What should I be putting in the decimator here? I didn't know if I said the word denominator, you might have been, what's he talking about?
Sine 27.
You're never going to live that down.
I just still remember
Please, who cannot predict the decimator? All right, I got a problem. I need your help fixing it. The other side I'm given is side T, which is 21. I'm not using 105, though. And the angle across is not labeled. What am I going to put here in the denominator? Oh, can I get some help here? How can you find what to put in the denominator there? It's not given to me. Oh, 1. Meg, a little help?
Just find it by adding those two stuff to
180 minus 105 minus 27. You got that value? You made it sound so easy.
48.
48. Yep, sine of 48. We're all good? Wow, we got 48. Jonathan, you good?
Yeah.
How about your group?
Sure.
Okay. Do you think you could take on best group in the nation over here?
I don't know, Juan's there, so that might be a little hard.
Oh, intimidated by the Quanster, huh? Everyone see what I did there? Monster, Quanster. Okay, never mind. Moving on. You didn't even get that triangle, so what the heck am I talking about? All right, go ahead. Cross multiply. Sine of 48 times D. 21 times sine of 27. And then divide both sides by sine of 48. And that side's going to be 13. Quick check. Does that seem right? Seem right? Those values in that positions? 27's across from 13. 48's bigger, and it's across from the bigger side. Yep. Looks good. You guys have any questions? Last thing I need to show you. You can find a side using law of sines. Now, how do I find an angle using law of sines? Not going to change much. So go ahead, triangle ABC now. Oh, let's see, what do we got? 112 in for angle C. C is 10. B is 7. What is angle B? Nearest degree. All right, let's do this. Do you know a sine and an angle relationship? We do. 10n sine of 112. So I can start there at least. Other side, 7. What are you guys going to put in the denominator here? Okay, we still got to put the word sine with it, though. You just can't plop an x there. It's the sine of x or sine of b, whatever you prefer. But sine still has to go there. All right, I'll put sine of b because we're finding angle b. If you want to keep x, find x. But I need the sine with it. All right, I'm going to slow down the pace here a little bit. Cross multiply. 7 times the sine of 112. And then on the other side, 10 times sine of b. We want to get sine of b by itself because eventually we want to get b by itself, right? We want to get b all by itself. So the first thing we got to do is get sine of b by itself. What do I need to do with the 10 then? What do I need to do with the 10, Jonah?
Divide it.
Divide both sides by 10. Good. So let's get the 10 out of there. So I get sine of b, and good, everyone's going to their calculators now, as will I. Sine of 112 times 7 over 10. All right, everyone's getting the decimal? That's not my angle, remember? That's not angle B. That's the sine of angle B. 0.6. Again, not my angle. It's the sine of the angle. So, and we have taught, hey, I'm not showing you anything new here in a minute. You know how to do this. You know how to do this. What angle has a sine of 0.64902, etc.? What angle, B, has a sine of this right here? Anybody remember how to find it? Find an angle. Find an angle. Find an angle. Whole day of it. Come on. Just had a quiz on it. Find an angle. Paul?
Let's do a negative sign.
Remember the inverse? Yes. So angle B is going to be equal to the inverse of sine to the -1 of this decimal. Now, hold on. This, I was crushed second period today. Actually, almost embarrassed for the kids that were in this class. Tell me please be honest if you did or did not know this. I go second sine. You do not need to retype that whole decimal in. Are we aware of that? You have like a copy paste feature on your calculator. Highlight it, press enter. So I could tell by your faces, some of you didn't even know that, did you? Oh boy. Wow. Look at that. You can go as far up as you want as long as you didn't clear out anything and highlight and paste it in there. So there you go. So you don't have to retype all those numbers after the decimal. Whew.
I didn't see it.
All right, it's not a magic act. All right? Not a magic act. Second sine. Now you want to put that decimal in there, right? Go up, highlighted it.
Just cleared it.
That's a you problem. Highlight it, Enter, it goes right back in. How about that? Which leads me to my next. Do you guys know how to use a fraction template? Alpha y equals, right? Get your fraction template up there. We good here, Tammy, or no?
Not really.
Well, get this decimal back up.
Yeah, but I was too busy like retyping the numbers.
Sine of 110 times 28 divided by
I
sine of,
did that.
or right here, sine of 112 times 7 divided by 10. You got that decimal?
Yes.
Second sign.
All right. Yeah, I did that.
Go up to highlight it.
All right.
Enter.
Got it.
We good.
Yeah.
Everybody else, all set? What are you, nearest degree here? Yeah, so 40 degrees.
What do you want? 41.
The 6 runs the 4 to a 5, and then the 5 runs the 40 to a 41, right?
What rounding directions are we coming from? Nearest degree, you just look at the first number after the decimal.
No, but I thought if it, yeah, and that's not how I learned it. Because it doesn't the 6 in the hundredth place turn the 4 in the 10th place into
If we were rounding to the
0.5?
nearest tenth, yes, it would be
But
0.5.
then that turns that into a 0.5, and the 0.5.
How far do we go, though?
Until you can't go.
So you're basically telling me, if one of these numbers is 5 or greater, always round up. That's basically what you're telling me. If any of these numbers are 5 or greater, you better round that sucker up.
We learned that, like, so if the hundredths is greater than a 5, then that makes the 10th place go 1 decimal higher. Then if it turns to a 5, then
It's just nearest whole number, you look at the first number after the decimal. Done. Anybody else go to the same schooling of decimals as those two back there? The kid who's telling me to call it the decimators telling me to round. Like, we're going to take your word for it. All right. 40 degrees, everybody. Whew. It's news to me. Because how do you just stop at the hundreds then? Or do I keep going to the thousands and the 10,000s?
well, if you had like 10.44445, then that would round to 11.
No, it's not. It
Yes,
does
it
not.
would. No, I still.
Any questions here before I lose my mind here? We all good? All right, you guys, you have plenty of time here. You got 17 minutes to start the homework, so use it. Use it.
Yeah, I got the one.
Let's go. Use this time if I'm giving it to you.